Hi everyone, this is how we did it Jamaica, and on this channel we want to focus on DIY projects. And in this first video I want to show you how I went from these concept drawings for this solar power generator to this final product. It's made up of a 3.6 kilowatt inverter with about 8 kilowatt hours of battery storage. A quick disclaimer before we go any further: I'm not an electrician, I'm just a DIY enthusiast, and this is my DIY project. So here are a few components that you need. Wires, of course, to connect the batteries to the inverter. Of course, you'll need circuit breakers. This is a 150 amp circuit breaker that you'll put between the battery and the inverter. Another set of wires there. The BMS, this is a 200 amp JK BMS with the power button and the temperature sensors. You have the display for the BMS as well as a display with a power button and the balancing leads. This will help to balance the voltage in the cells. And this is just a voltmeter. I use those to connect the panels. I might decide not to use those going forward though. Here you have some Anderson connectors. I think I might use these to quickly be able to disconnect power from the solar panels. You can see the MC4 connectors on the end as well as the wires for the solar panel. Here you'll see some battery terminal lugs coming up right there. So these are the circuit breakers that I'll be using for the output of the inverter. They are rated at 16 amps each. And here you also have some DIN rail power outlet modules that I can use to plug in extension cables or plug in appliances. This is a circuit breaker that I'll be using for the grid input. It's rated at 32 amps. And here you can see some other components and tools that I used. Wire strippers, wire crimpers. There you can see the DIN rails to the side, the bus bars for the batteries. And the batteries that you'll see coming up are 3.2 volts each cell, 3.2 volts by 320 amp hours, and those are lithium iron phosphate cells. Now here's the inverter. As I mentioned, it's a 3.6 kilowatt inverter. The max PV input for this inverter is 4200 watts or 4.2 kilowatts. The max current that it will take from the panels, 18 amps. The PV input voltage range is 60 volts DC to 450 volts DC. And the max voltage from the PV is 500 volts DC. When it comes to the AC input or the input from the grid, the max current it will take is 40 amps. And the operating voltage is 110 to 120 volts AC. For this type of inverter, you must be using a 24 volt battery. And the max battery current is 150 amps. When it comes to the AC output, you're looking at a nominal output current of 30 amps. Now on to building the battery pack, and this is what I did. Use some sheets of ply. These ply boards were previously used for formwork, concrete formwork, so basically these are reused ply boards. Now the two pieces that are in my hand will basically form the outer sides of the battery pack. These will go on either sides of the battery pack to provide a bit of compression to hold the cells together and to kind of prevent them from expanding when they are charging. This piece is where the battery packs will be standing on, and you can see some wheels on them to kind of give me the ability to move it around. On the metal rods that you see on the left hand corner of the screen, Those are threaded rods, and those I'll be using along with some nuts to basically add the compression, tighten them down to add the compression to the battery packs. Here you can see how this will look. Now I'll be loading the battery packs in. And here are some specifications for the batteries. You can pause the screen and view them. These are what the battery packs look like. 320 amp hour, 3.2 volts, weighs about 12 pounds per cell. Yes, about 12 pounds per cell. So with 8 cells, it's quite heavy. So here you can see me arranging the batteries in series. So basically the negative and the positive terminals on the batteries are closest together. So for series, this increases the voltage of the battery. If you're arranging it in parallel, it increases the amperage of the battery. So here you can see the bus bars, and I'll be connecting the positive on one cell to the negative on the other cell. So basically I'm increasing the voltage. I can't stress this enough, ladies and gentlemen. Please use proper safety equipment when you're doing this. If you do it, that is. As I said, I'm not an electrician. I'm just doing my DIY project here. Here I'll be adding the BMS, what you call the battery management system. And this is used to basically monitor the voltage so you don't overcharge the battery cells or undercharge them. It also manages cell balancing. Here's what the wiring diagram looks like for the JK BMS. I mentioned cell balancing. Now this is where the BMS tries to keep each battery cell at a certain voltage level. They try to keep all of them at a similar level, and this basically reduces the risk of overvoltage or undervoltage in a specific cell. So the BMS, if say you're charging the battery, the BMS will try to redistribute power to each cell and try and keep them at the same level. Now, I had to do a ton of research on these things, so forgive me if I'm not explaining it properly, but you can find other resources on YouTube. There are some great channels such as Off Grid Garage, Will Pros, or Will Prose, I think that's how his name is pronounced, and some other DIY channels with people doing their own thing. So check out some other videos. You'll probably get better explainer videos on BMSs and battery packs and stuff like that. But as I go along, I'll try to explain some of the other things that I did, and maybe in future videos I'll be more detailed with how I break things down. So maybe you should just subscribe, and we'll see how it goes in the future. Something that I noticed after I completed this project, I realized that maybe I should have put the balancing leads below the bus bar, because when I was turning the nuts, they basically turned the leads while I was tightening them down. So that's something that you can note and probably do in your own build. I can't stress this enough. Try to use proper safety equipment if you're doing these things, especially if you're not an electrician like myself. It can be dangerous. So again, the size of this battery pack is about 8 kilowatt or 8,000 watts, and during my testing I think this was able to run my 19 cubic feet refrigerator for about a day and a half. If you guys want me to test something to see how long something runs on this pack, I'll be happy to do so. However, I think I may be doing an upgrade soon. I think I want to upgrade to a larger inverter, probably a 32 kilowatt hour battery pack. I want to power them the whole house, so let's see how that goes. Another important note is you should follow the wiring diagram very carefully. During this build, I did make a mistake and I had to basically pull down all the wires, remove all the wires, and then I had to rewire it. And it took me a little bit of time, but eventually I got the correct order in which the balancing leads should be attached, and then I was able to attach these temperature sensors. Now here you can see temperature sensors attached. Now we're attaching the display. This display has a power button on it, so I'll be able to power the battery pack on, and you'll be able to see the current state of charge of the batteries. And as you can see from the factory, it's at 62%. This BMS does come with an app, and you can see the app from the start right there, that what it looks like, and this is what it looks like when you enter the app. The password, I think it was 123456. When you just you have to actually verify the password if you want to make any changes. And you can see some of the battery settings that I used. Actually, you can basically go with the default settings. You just need to change the cell count and the cell capacity. So for mine, my cell count is 8, so I'm using 8 3.2 volt cells, and the battery capacity for each cell, it's 320 amp hours, but I'm using 315 amp hours just to be safe. Here you can see that you can actually disable charging or discharging or balancing if you want to. And the settings, I think it's quite comprehensive. You'll be able to basically customize this in ways that you want. So just remember, if you want to make any changes, you need to enter the password. So that's basically it. This was actually part 1 of a 2-part series, and this is basically the preview for my next video, where I'll be finishing up this solar power station. So thank you again for listening. I really hope you enjoyed. Please remember to subscribe.